Action. Okay, so let's sound like a high school science teacher. All right? What is periodic behavior? What is periodic behavior? Anybody know? Anybody ever heard of periodic behavior? Who's heard of periodic behavior? Anybody? No? Did you go through a stop sign this morning? Or not a stop sign. Did you go through a stoplight this morning?
Yeah, yellow
Right?
to red.
Yellow to red. So did you stop at one? You exhibited periodic behavior. All right. You experienced periodic behavior. You obviously woke up this morning and you were alive yesterday and the day before that and the day before that, right? So you all experienced periodic behavior. All right. How many of you guys have ever seen a sine wave?
What?
I don't think you can see that.
How many of you have ever seen a sine wave drawn for you? Anybody? Or ever seen that symbol? Right? That's periodic behavior. Okay? All right? And so this light that we're looking at today, any warmth that we experience when the sun hits us is all forms of electromagnetic waves. And we already saw this in one of our previous lectures. All right? And we don't need to know a huge amount of the physics behind periodic behavior. We just need to understand a few basic concepts of it. Okay? So one of the things that I want you guys to be aware of is that that is periodic behavior. Anybody use their turn signals on the way here today? Some of you did, right? So, right? So light intensity went from 0 to completely on and stayed on for a certain amount of time, and then it turned off, and then it was off for a certain amount of time, and then it turned on, it was on for a certain amount of time, and then it turned off, and it was on a period, right? Tick, tock, tick, tock. Correct? It's periodic behavior. It is a repeating cycle. Right? If I had how many of you guys have been to the Griffith Observatory? Anybody? Do they still have that pendulum in the middle? It goes, and it swings back and forth. That is exhibiting a form of periodic behavior. Okay? The wave for that one is going to look more like this than this. Okay? Your heartbeat, right? Your heartbeat is contracting and then relaxing, right? And it takes place approximately, depending on the person, right? Your heart beats about every second, okay? The average heart rate right now in here is probably going to be about 70 beats per minute. So it's a little faster than once per second. But the same thing is occurring. You've got some form of a repeated behavior. Does that make sense? Okay, so let's talk about some thoughts on this. I'll extend this one further forward. So most of the time when you guys have seen in a science class or something like that, something that looks like a sine wave, right? It's perfect, right? I mean, it's the same everywhere. But periodic behavior isn't the same everywhere. If you look at your heart rate, it's not going to always be perfectly regular. Okay? So let's talk about a few things. For starters, the amplitude. First of all, there are two axes when you study periodic behavior, right? There is the center line or the baseline. There is a vertical scale that can be a number of different things. Okay? And then there is a horizontal scale. And the horizontal scale can be a number of different things, but usually the horizontal scale is time. All right? So we'll call this magnitude, We'll call this time. Okay? So time could be in millions or trillions of a second, right? So from here to here could be 1/1,000,000th of a second. From here to here could be 1 second. From here to here could be, a week. So this is just time in a sort of generic sense, okay? The amplitude of the wave is the distance up, okay? So the amplitude of the wave relates to magnitude, all right? The period of the wave, or the frequency of the wave, relates to time. It is the distance for it to go through one entire cycle before it starts to repeat again. Okay, so that's frequency going in that direction, amplitude going in that direction. Does that make sense? I'm guessing you guys may not have not known the words, but you kind of have heard this before somewhere. Okay. One of the things that's going to be really important to your study of architecture is going to be comparing two types of periodic behavior. And again, we're talking about this in the complete abstract, but by the end of this, we'll have tied it to something that means something to you guys. All right? So if I do something to whatever is causing this periodic behavior, right, to squeeze it down, that is called dampening. And so dampening is going to take and create a wave. Let me use a different color. It's going to create a wave that is not going to be as intense in either the upswing or the downswing. That is called a dampened wave. Okay? One other concept that I want you guys to be aware of, and I'll do this one in green, is when you have a delay in the wave. And that is called phase shift. So if the wave, instead of starting here, if we did something to it and it went like that, it's shifted over from its normal starting period and it is ending later. Okay? So it's like, okay, this is an architecture class, not a science class. Why are we talking about this? Does everybody have a phone? Everybody has a phone. Very good. What I'd like you all to do, and I think I'll turn this and point it over at the screen. How many minutes are we at, by the way? 8? Does that see the screen?